Welcome and hello. This is a video exercise in HEC HMS, and in this exercise, we'll be working with optimizing gridded precipitation. So this is actually a follow-up exercise to exercise 6. I would recommend you do exercise 6 first, dealing with precipitation grids and transposing them, but if you haven't, that's all right too. What I have on the screen here is the website that has the files and the instructions for this exercise. So I will leave a link to this website in the description of this video. So you can go ahead and follow along. First step, let's go ahead and download the starting files, the project files right here. So I'm just going to click here and then click download, wait for that to download. And there it is. All right, so we can close this. And then here are the files. I'm going to go ahead and open up that zip file and see what we got. All right, so we have a project directory here. I'm going to go up one level and then just copy that into the location I want it to go. That's right here. Okay, that's copied and ready to go. So I'm going to go ahead and just delete the zip file and then open HMS. So here's HMS. I'm going to go ahead and open up that project we just downloaded right here. Okay, punks.hms and select. All right, so what we have in the Watershed Explorer is a basin, as well as a number of meteorologic models, control specifications, and so on. All right, I'm going to go ahead and expand the basin view and the basin map. I'm going to toggle off some of these map layers. We don't need to see all that. So that looks good. We have our Punks watershed with 3 subbasins and an outlet right here. Now in the previous exercise, we started with gridded precipitation dataset and we ran a simulation for the first 14 days of September, and we measured the peak flow and total volume that came from this outlet right here. After that, we transposed the center of the storm closer to the watershed and then again ran the simulation and then saw the increased peak flow and volume values. Now, the question we want to answer in this exercise is what location for the center of the storm on an XY axis would optimize or maximize the discharge or peak flow at this outlet location? So we're going to use the HMS optimization tools to answer that question. The instructions on the website are broken down into multiple tasks. The first task is to set up the optimization trial. So I'm going to go up to the compute menu and then click on optimization trial manager, click new, and then type a name out. I'll paste in maximize peak flow and then click next. This is a 3-step wizard here, where the next step I need to select the basin model. So I'll select our one and only basin model, click next. And then in the third step, I need to select the meteorologic model that I want to use. And the instructions say to use the 2018 transposed model and click finish. All right, so now we have our optimization trial right here. I can also see that in the Watershed Explorer. If I go ahead and click the compute tab right here and then expand optimization trials, I now have maximum peak flow. Next, we're ready for task 2. That's to define the search parameters and set the objectives. So in the Watershed Explorer, I want to go to this compute tab, which I'm already at. And for the maximum peak flow, I need to set the start and end date times. As you can see, we already have some data set already here, which is the DSS file, output all. I'll leave that as it is. The basin model, this is what we selected earlier, as well as the meteorologic model. We selected these two here, but we can change them if we want. The instructions say to use a start date of September 1st, 2018, and then an end date to be September 16th of the same month. And then a start time would be 0 hours and an end time would be 0 hours and a time interval of 1 hour. So that's the data that we need for the optimization trial tab. I'm going to select the search tab next, and then after that, objective. So the search tab, we're told to put in the search method is simplex. So that's what it is already. Max iterations is going to be 100. That's what it is. Tolerance, 100th, 0.01. That's correct. And then tolerance criteria will also be absolute. So all the default values are what I want here. Then the last tab here is objective. So my objective here is going to be the goal. The goal is going to be maximization. So it was minimization. I'll change that to max. Next, I need to select the location. And what I want to do is select the gauge here, which is the outlet of the watershed, which is Mahoney Creek gauge at Punks. Next is the time series, and I want to select discharge. That's what it is. It's my only choice, it looks like. And then statistic is going to be peak discharge. This is what I want to maximize. And then data transformation, I'm going to say no transform. So I'll go ahead and click save on that. Task 3 is next. It says to add gridded precipitation parameters. So while we're here in the Watershed Explorer, I'm going to right click on my maximize peak flow optimization trial, and it gives me the option to add a parameter. These parameters are the decision variables that can be used to find the optimal objective function value. So I'll go ahead and select add parameter and then click parameter 1 to bring up the components editor and define what that parameter is. For element, I want to select precipitation parameters. And then below that, the parameter I want to select is going to be x coordinate. So the gridded precipitation x coordinate value. Now, what popped into place were some default values. So this value right here is the initial value in feet using that XY coordinate. So this would be the X value. And it's also based on the selected meteorologic model, which I selected to be the September 28 transpose model. I'm going to just leave the initial search location right there. It's got to be fairly close to there, I assume, and then I'll leave locked for no. The last two fields here set a minimum and maximum search range for this parameter, which is the x coordinate. And this is a ridiculously large range for x. I don't want the simulation taking forever because it's searching all over the place. Realistically, the optimal location would be in the general area for the storm center, not 1,000 miles away. The instructions say to set values here. They provide a minimum x and a maximum X location right there. So just go ahead and paste those in and click save. There is a second parameter I need to provide, and yeah, you guessed it, it is the Y value. So I'm going to right click, add a parameter, select parameter 2, and this is also going to be precipitation parameters Y coordinate. Just as before, we'll leave the initial value and then go ahead and set new values for minimum and maximum. That will be the minimum value, and then that's the maximum value right there. And then click save. Okay, the next task 4 here is to view and interpret the results. Of course, we have to run the trials as well. So up here we have our trial, maximize peak flow at that outlet. I'm going to go ahead and select that and then click the run. So what you're seeing here is a number of iterations. It's working, and let's see what happens. Down here, you notice that it is tracing out the X and Y values that it's searching through, which we'll be able to see in a plot at the end. Okay, looks like the computation was done in 18 seconds. Let's go ahead and check out some of the results. I'm going to head over here to the Results tab in the Watershed Explorer and then expand Optimization Trials. The objective function is now 11338, which is the flow rate. This is the peak discharge at that outlet location. Here is the table of peak discharges. So I have optimized highlighted in yellow here. We just had 11,338, which is certainly larger than the 3 trials that we were experimenting with in exercise 6, where we first had an observed value of 8,637, and then we transposed it with a bias. Also, it's interesting, but the optimized peak discharge does not correlate with a maximized volume discharge through that outlet. But this was the parameter we were seeking to maximize, so it looks like that worked. Or at least it was larger than these other 3 trials. The next result down is optimized parameters. Here we have the initial value of the x coordinate and the optimized value of the x coordinate. And then the same with the y coordinate, initial and optimized. So our optimal values are x and y right here. And as we saw in the trace, we saw the different iterations of x and y values it was searching through. And we can also look at those traces in a plot. So this right here is the X trace, which shows the X storm center coordinate for the different simulations. It looks like it converged around like 34 or 35. Here's the Y coordinate. It looks similar. There's a lot of variation in the first 10 or so iterations, and it finally found its optimal value a little bit later on. The objective function here shows, wow, okay, it's went down to 0 for a little while and then popped back up to its final value of 11,338, was it? So that's interesting. The tutorials shows this map here where we have our sub basin for the entire watershed up here. And then we have the original observed calculated location of the storm center down here. The transpose value was right up here. And then the optimal value, surprisingly enough, was right here in green. So hopefully you can see that enough, but it was a little counterintuitive that the maximum outflow through this outlet at a watershed up here would actually result in higher flows if the center of the storm was further away. These coordinates here are in meters. They're not the same values that I had up on the screen earlier, which were in feet. Task 5, the last part of this exercise, is to create a new meteorologic model and simulation run and then show the spatial results. I'm going to click on the Components tab here, and we want to create a new meteorologic model for optimized. I'm going to go up to Components Editor, Meteorologic Model Manager, New, and now I'm going to give it a name, September 2018 Optimized, and click Create. So that one's right there. Now, what I want to do next is open up the optimized meteorologic model. And then in basins, I want to say, yes, include these subbasins for the September 28 basin. Save. And then back to the meteorology model tab. I need to change the precipitation to gridded precipitation. I'm going to save that. And then in the gridded precipitation icon, I want to select the QPE grid. This is the main precipitation grid that all the meteorologic models are using. Time shift, I'm going to leave that at none. And then for transpose, I'm going to say yes. And what I'm going to do here for my offset, these are the absolute coordinates in feet for the center of the storm. I'm going to actually use the values that the optimization trial found. The X coordinate for the optimal center of storm was right here. And then the Y value is right here. And then I'm going to leave grid bias off. Okay, I'm going to go ahead and save that and then create a simulation run using this optimized meteorologic model. Compute menu, and now create compute simulation run. I'll just call this the same thing as the meteorologic model, September 2018, optimized, and then next. Next, we will select the basin. So that looks good. Next. And then now I need to select the optimized meteorologic model. That looks good. Next. And then finally, the control specification, the only one we have here, and finish. So let's go ahead and run that now. I'm going to select the run for 2018 optimized here, and then go ahead and click run. Next, I'm going to go ahead and just look at the results. We'll look at the global summary results here. And for our gauge at the outlet, this last row here, we see the same peak outflow as before. Now, the instructions say to go ahead and analyze spatial results. And for some reason, I'm not able to do that. So if you are, then let me know what I'm doing wrong. Because when I select one of the other runs, then I can select the data for that. 1 second. Right. So it allows me to actually demonstrate that data when I select a different run, but not for the optimized run right here. See, I don't have any options to select. And in my defense, I also downloaded the final files provided at the bottom of the website, loaded it up, still couldn't get it to work. But what it wants us to see is just to compare the observed spatial results for cumulative precipitation, which is what we're seeing in this screen here, which certainly has less precipitation compared to the optimal precipitation run, which would be right here. And I can't hover over the image and get values like I would if it was working in HMS for me, but you can see that the scale shows just higher precipitation values. So that was it for our exercise here, dealing with the optimized gridded precipitation. It's really a follow-up to exercise 6, where we transposed gridded precipitation data. And we ran a simulation, we set optimization parameters, and then we found optimal values based on our specifications.